Hello, finance experts. Today our project will be analyzing a set of funds, and what we want to argue that by looking at the Sharpe ratio of these funds, basically the Sharpe ratio is a measure of historical risk-adjusted performance. So what we're going to argue is that the higher the Sharpe ratio on those funds, so the higher the Sharpe ratio, the higher the returns. So what we have here is on column C, the symbol, that's those are the funds that we are analyzing. Column D, we have the Sharpe ratios. Column E, we have the 1-year returns, the annualized average return for these funds. And in column F, we have the 3-year annualized average return for these funds. So what I'm going to do is we're going to do first a regression analysis and to analyze this data. So with the regression analysis, first we're going to analyze the 1-year return. So basically, we're going to do a regression based on the Sharpe ratio and the 1-year return for these funds. Okay, so on this tab here, we already ran the analysis. So we have a regression analysis on the 1-year return. The X variable on this regression data analysis is the Sharpe ratio, and you see the Sharpe ratio right here. The Y variable in this analysis is in this tab the 1-year return column that we have. So as you can see, we have a T-stat of 2.74972. What we're looking at is a T-stat above 1.65 or below negative 1.65. So it is significant. Okay, the significance here shows that we have some significance. The coefficient is on the the p-value. What we're looking at is a p-value below 0.1 or 0.05 or 0.01. So here we have a p-value of 0.01141. Again, it's very close, but we have some significance. So the Sharpe ratio here, basically what we're arguing is that the higher the Sharpe ratio, the higher the return. So basically we were expecting a positive number, and that's what we got here. Not a very high number, but a positive number here on the coefficient for the Sharpe ratio. So we were expecting a positive number based on our argument that the higher the Sharpe ratio, the higher the returns. Okay, so now we're going to move over to the analysis, the regression analysis on the 3-year return. So with this, the x variable is still the Sharpe ratio for these funds, and the y variable now is the 3-year return, 3-year average returns for these 25 funds that we picked. So again, we see under the coefficient, Sharpe ratio, positive number, so that's what we were expecting. The higher the Sharpe ratio, the higher the returns. That's what we're arguing. We got a positive number there. Okay, the t-stat in this situation as well, above 1.6, positive, above 1.6, a little close to 1.6, but again significant. We have a p-value of 0.0574. So with a p-value of 0.1, 0.01, and 0.05, that shows us significance. Okay, on this data analysis. Okay, so we're seeing some relationship on this data analysis. Okay, so now the next thing we're gonna do is actually we basically sorted out both for out of the 25, the 10 funds that had the lowest Sharpe ratios. So sorted here by the lowest first. So you notice the 10 first lowest Sharpe ratios here. Their 1-year return and the 3-year return. Okay. To the side here, what we did then is out of the 25, we then selected the 10 funds that had the highest Sharpe ratios. So we ditched the other 5. So now we're comparing, we have a total of 20 funds, 10 being the lowest Sharpe ratios and 10 being the highest. So we have two sets of data. One is going to compare between the 10 highest Sharpe ratios, the 1-year returns and the 3-year returns on the high end. And the other set of data is looking at the 10 lowest Sharpe ratios, and we're going to look at their 1-year return and their 3-year returns. And so what we're going to do is we're going to run a different set of analysis now. First, we're going to do a difference of means. Well, first we're going to do a 2-sample test, and we're going to assume unequal variances. Okay. So the first one, we're going to look at the 1 year. And so basically we're going to compare the 1-year return, and we're going to compare the low to the high. Okay. So we just ran a 2-sample test, t-test, a t-test, 2-sample assuming unequal variances. Okay. So as you can see, we are comparing the 1-year returns on all the stocks, the funds that had the 10 that had the lowest Sharpe ratios and the 10 that had the highest Sharpe ratios. So the mean, the average, the mean for these sample is the 1-year returns having an average of about 2.74% return, and with the 10 funds having the highest Sharpe ratios, the 1-year return being 8.47%. So we see significant higher returns for the funds that had the 10 highest Sharpe ratios. Okay, you can see here the variance very low. We had 10 observations. Okay, the t-stat, what we're looking at again is above the t-stat of above 1.65 or negative 1.65. So we have a t-stat of negative 2.27. Again, significant. And then we're looking at the p-value. Looking at the one-tail p-value, 0.02 is below. And the p-value of a two-tail, 0.04. Okay. So we see some significance here. Now let's take a look at the 3-year, comparing on the t-test for two samples assuming unequal variances. The funds that had the 10 lowest Sharpe ratios, comparing their 3-year return against the funds that had the 10 highest Sharpe ratios, comparing their 3-year returns. So again, we see the same averages. The 3-year return, the same differences, about 3.71% on the 3-year with the low Sharpe ratios, and about 8.15 with the funds that had the highest Sharpe ratios. So again, we're seeing significant data showing us that the average for the funds having the highest Sharpe ratios, they had a higher return. Okay, the variance is very low. We had 10 observations. Again, t-stat here, negative 2.41, below negative 1.65, so we're seeing significance. Okay, on the p-value, we see on this set of data for the one tail, 0.0136. Okay, so below that, 0.01, and the two tail, 0.02. Okay. Now, since we assumed that unequal variances, we also wanted to run a test comparing doing a pair two samples for means, just to just be sure we have some accurate data here. So again, in this situation, we are comparing the 10 funds that had the lowest Sharpe ratios to the 10 funds that had the highest Sharpe ratios. We are looking at the 1-year returns. So we see again the average, the mean of 2.74 for the low, 8.47 on the high. Okay. So we were expecting that, in our argument is that funds with a higher Sharpe ratio tend to receive higher returns. Okay. Variance very low, comparing 10 observations here. T-stat, we even higher t-stat, above negative 1.65. We have negative 2.96. Okay. On this situation, the p-value is even more significant, 0.0078. Okay. And the two-tail, 0.04. 15. Okay. Now let's take a look at the 3-year low and high. So again, this is comparing the 10 funds that had the lowest Sharpe ratios and the 10 funds that had the highest Sharpe ratios. We see the same means here, about 3.71% average on the low, 8.15% average on the high. Variance very low, 10 observations. The t-stat is even more significant, minus 3.85. So we see some significance in this data. The p-value here on the one tail, 0.00196. So below 0.01, 0.1, 0.05. Okay, so very significant. So in light of the data that we gathered and the analytics that we ran, we see that our argument that funds that have higher Sharpe ratios tend to have higher returns. And so we're seeing significant data analytics telling us that this is rather accurate. So with this is the end of our presentation. Thank you very much.